B dot B bar, that will be equal to 0. And then from the previous one, X or with 0 will be equal to X. This is equals to A. A and with A bar, this, we know it from here, is equals to 1. And then here, X and with 1, no, X or with 1 will be equals to 1. So 1 or with B, that will be equals to 1. That is using the fourth and the second law. A or A bar was equals to A or A bar is equals to 1. This bit here is equals to 1. One and B, what's that equals to? So X and with 1, that will be equals to X. So that will be equals to B. We break the bar, change the operator. We have A bar, or become N, and then we have B bar bar. And we know that B bar bar is equals to itself. That's the solutions to that. The next one, number 5. The operator is here. So we can break this bar and change that operator. So we start with A bar, B bar. And then we break that bar. So here we can actually carry on with our De Morgans. So here is another operator. We have a bar and then we have an operator there. And same thing here, we have a bar, we have another operator there. So we can break that. That will be A bar bar. And so this will be A or B, and with B bar or C bar, or that's the solutions to this. Do you know where you got it wrong or? Yes. So it's important that you have the brackets, because if you don't have the brackets, you mean something else. If I don't have a brackets, then there will be A, B, and with B bar. The bracket there is important. Just like your normal algebra. The clue is from De Morgan's theorem. We know that from De Morgan's theorem, we can change the operator. So we have AND gates. No, we have OR gates here. So NAND gate is an AND function. We can change from OR to AND from De Morgan's. So how do we do that? De Morgan's. That's De Morgan's. But we want A or B. Another clue is from here. And then another one useful is this one. All this law, you can apply all this law to make it works. A or B. How do I make it in terms of something like this? From here, yeah? There will be A plus B bar bar. That's my starting point. Then I can apply De Morgan's. Apply De Morgan's, what do you get? This itself is a NAND function, yep? Correct? But how do I get A bar? I want a NAND gate using a NAND gate. How do I inverse the A function? So it's from here. X n with X is equals to X. Meaning that A n with N, A n with A is still A. B n with B is still B. This another NAND functions. This is one NAND gate. This is another NAND gate. So I can build an OR gate. Here is my OR gate. And here is also equals to my OR function. This is one way of doing it. We also have another law. X n with 1 is equals to X. So we also can achieve this using A NAND with 1. This will give me A bar. B NAND with 1 give me B bar. And then here A bar NAND with B bar. They give me A or B. Anyone lost? Lost. Let's do it again. We start off with A plus B. We want to achieve this using a NAND functions or a NAND gate. So one of our laws says that if I double inverse a function, that will be equal to the function itself. We understand this. Meaning that if I inverse A or B twice, that is the same as A or B. Agree? Anyone don't agree? And now we can apply De Morgan's. We can break this bar. The top one we keep. So the top bar, we're not doing anything with it. The bottom one, we break it. And then we change the operator. That's De Morgan's. This itself is a NAND gate. So if I assume that A bar equals to X, B bar equals to Y, this is X, correct? Agree? So if my X bar is, no, my A bar is equals to X, my B bar equals to Y, so this is X dot Y with a bar on the top. Yep. So this is my NAND function. I can easily build this using a NAND gate. Except that my X is a bar. How do I achieve A bar using a NAND gate? We want to achieve A bar using a NAND gate. To do that, we can either use the other law, said that X dot X is equals to X. This is another law. So meaning that I can say that A dot A is equals to A. So if I put a bar there, put a bar there. Right? It's the same thing. Because A dot A is A. A dot A with a bar on the top, that is simply A bar. So we can achieve this using A through a NAND gate. And this will be if they are both the same, we can tie them together and just put it through to A. Same thing for B. That is how you can achieve that. So meaning that if I carry on from here, still not following? Yes? The final answer is the one at the bottom. The red one, yeah. So this is the circuit. If I want to implement it, this is the function that I need. This one not finished. Not yet finished. Okay, because my signal is A and B. I need to know how I can invert A and B. This is one way of implementing. The other one I said just now is the other functions. or the other property, x n with 1 also equals to x. So this is one answer. Another answer is so this is the second solution. The second solution is the one in the black. We can either tie the two inputs to A to create an A bar, or we can use A and then the other input we put it to a 1, which means that in your circuit, if TTL, I'll put this to 5 watts. Okay, I put one input to the 5 watts, then my A here will be my A bar, and here will be B bar, which means that I put one of the inputs to be a logic 1 or to a high voltage, then the output will be an inverse of the other inputs. This is the second solution. Either this one or this one. Is that okay? This is a simple operation, just OR. So question can be extended to maybe XOR and ask you to implement it using a NAND gate or using an OR gate, for example. This should be a simpler one. Implement A or B using a NOR gate. So NOR gate is we want to implement an OR functions. If I put A and B to a NOR gate, I get this. But I want this. You need something else here to give you A or B. How do you do that? But you need to use NOR gate as well. If you could use any gate, I just put an inverter there, I get A or B. Yeah? But how do I achieve an inverter function using a NOR gate? Like the one we do before here. I achieve inverter here using a NAND gate. How do I achieve inverter here using a NOR gate? Again, let's go back to the law that we talked about earlier on. If I let x equals to a and b, so this will be x bar. Here will be simply x. So I got a signal x. How do I get x bar coming out from there? Through an AND gate. Go back to my law. One of them is this. You can use this, or you can this is one solution. This is another solution. So just now we have x. We want to put it through a NAND gate to get x bar. Any idea? NAND gate, again, remind you what is not NOR gate. So if I put this, what happens if I put this through a NOR gate? What do I get? Correct? Agree? Is it? Do I get an inverse? How about this? Correct? This will be x 0. So this is x plus 0. Everyone get that? Everyone not understand? No? Don't understand? You understand this one? Yeah. x, O with 0 is x. My NOR gate, O function, right? You know O function, right? So x, if this is 0, this is x, O with 0, correct? O gate. Yeah. If I put my O gate output through a NOT gate, so this is equals to x, right? Based on this identity. X, O with 0 is equals to x. Put my x through a NOT gate, this will be x bar. Alright? So this thing here is my NOR gate. NOR gate is O and then NOT. So if I put x 0 through a NOR gate, then I'll get x bar. No, still not. NOR gate is actually made out of O gate, NOT gate. A, B, A plus B bar. A, B, here is A plus B, and then put it through an inverter. And that is what a NOR gate is. So just now we have x plus 0 is equals to x. If I put x 0, meaning that I put this to ground through an OR gate, I'll get x plus 0. Alright? This equals to x. Agree? If I put x through my NOT gate, I get x bar. Yeah? So meaning that if I put x through my NOR gate, I'll get x plus 0 bar, that will be equals to x bar. I can inverse my signals by putting x to one input, put the other inputs to ground, then I get an inverter from a NOR gate. Or alternatively, I can do the other property is x plus x equals to x. So this is one solution. Second solution, x, give me x plus x, and that's equals to x. Again, put this through my inverter, I get x bar. So this is the same as x through a NOR gate if I split my input into two, so this will be x, this will be x, I'll get an x bar. Everyone understand? All I need to do is now put this through I'll get A or B. Okay, so I'll start off with A, B, go through a NOR gate, I get A or B bar, and then I inverse it using this NOR gate, I'll get back A or B. And that will be my original functions. This is one implementation. Second implementation will be put this to ground. I'll get A or B. That is your universal gate, how you can implement it using NOR gates or NAND gates.